Hello guys, welcome back to my channel based on African motives. Still working on mathematics for A level, pure maths. So in this platform we have got mathematical induction, working and solving statements that we have to prove and so forth by induction. That is mathematical induction. So if you're new guys, you can consider being part of the family by subscribing to Maths on African motives, and also don't forget to share our platforms to your friends and colleagues so that they also can benefit from this information. So before I introduce some questions, I just want you, maybe you can just have some of these notes down. They're gonna help you for induction, the principle of mathematical induction, whereby we have a system of number that allows us to prove statements about positive integers. Take note, positive what? Integers. So we're talking of statements that are going to be focusing with positive integers. In this case, that is what we are referring to. So I shall explain all these the properties that we have when working with induction. The introduction, the first thing is to introduce a statement, okay, that you're going to use to say let this Pn be the statement of whatever that you have. Then P1 is supposed to be true by substituting the value of k, which is equal to 1, n which is equal to 1, the value of k, and pk plus 1 is also going to be. So I shall show you how you actually prove this, and also don't forget that you're supposed to put a conclusion. All right, so these are the some of the conclusions that you can take for Pn. All values are true for it's a conclusion, or you can say since P1 is true, Pk is true, therefore it applies that Pk plus 1 is also true by mathematical induction. So therefore Pn is true for all the elements, or for all the values of n that you are referring, which are elements of what? The positive integers. Or you can conclude by this statement, guys, that is what you have there. So I think I might waste a lot of time just showing you what we have. So in this case, we've got some nature of questions that we have, and the first part that we have that I'm going to start with is on divisibility. All right, that is the first part that I'm going to start with, or you are referring to multiples. All right, that is multiples. In this case, that's a multiple, guys. Okay, multiple, exactly. So if you are working with multiples, let's say divisibility, let's consider terms that we know. Actually, there are terms that we know in mathematics, or numbers that we know in mathematics. Let's consider something like this. If we are given a number 8, I'm referring to numbers, then we talk about what we want here. So that is the first part that I want us to say. Let's say we've got a number 8. There are numbers that are factors of this number, which is 8. We're talking of numbers such as 8, 4, 2, 1. If we are to divide 8 divided by this by any of these numbers that we have, we are going to obtain exact values. So it actually means 8 that we are having here is a multiple. We are referring to 8 as a multiple of these numbers. These are the factors. If you are not just saying here, these are the factors, and these become a multiple. So it means when we divide by any of the factors, we must obtain what? An exact value. That is what we have. But now, the issue is we want to prove a statement, not just numbers, but it will be a statement. A statement like which one? Let me show you one of the questions that I want you to work with you here. We have got this person here, guys, that is proved by induction that this statement that we are given there is divisible by 4. Alright, that is the first question that we have here. This is divisible by 4. So if it is divisible by 4, what does it mean actually? That means for any value of n that we have that we are going to substitute here, talking of positive terms, if we divide by 4, we are going to obtain an exact value. Like maybe if you substitute, you obtain a number like 8, then you divide by 4, you get to it's divisible by 4. Maybe you substitute the value of n, you get a number like 28, then you divide by 4, you get an exact value. That is what this part actually means that we are having here. So if that is the case, that this expression that we have here is divisible by 4, I'm going to introduce as a statement now, like you saw from our notes. We said we are going to introduce a statement, so we are going to let Pn to be the statement now that we are given here, which is a 3 to the exponent of n minus 2n minus 1. This is our statement now that is representing what? Pn. So the first thing, when n is equal to 1, this is the first part that you want to prove to see that this is true. So when n is equal to 1, it means P1 in this case, if you are to substitute 1 in place of P, P1 must be what? Must be true. So let's see if it is going to be true, because we have seen it must be true. So we want to prove that it is going to be true or not. All right, so this is the case, guys. All right, let me substitute the value of n, which means 1. In this case here, you substitute 1, it means we have got 3 to the exponent. Let's just write as P1 so that we don't confuse each other. So that will be 3 to the exponent of 1 minus 2 times 1 minus 1. So I want you to simplify properly. In this case, you're going to obtain a 0 in this case. So obtaining a 0, what does it mean? To obtain a 0 in this case, what does it mean? Let's divide 0, divide, it is divisible by 4. So if we divide by 4, we are going to obtain an exact value, which is a 0. So that means this is true. Okay, so which is what? Divisible by 4. All right, so if this is the case that we had on n, which is equal to 1, then from our notes we said if n is equal to k, then pk is what? Is true. So you have to find pk when n is equivalent to k, and this is supposed to be true. All right, so this is what I'm going to do here. For this one, I'm going to, okay, let me just write when n is equivalent to k. That means pk is also true. So this means what I'm going to do in this case is to substitute now in place of what? In place of n, I'm going to substitute with k. So in place of n here, we are now having k. We are now having k. So it's going to be 3 to the exponent of k minus 2k minus 1. So this is what you're going to do, guys, if you are working with divisibility or a multiple. All right, you are going to equate this, okay, your pk, you are going to equate this 3 to the exponent of k minus 2k minus 1 to the number that is divisible, that the one that you are dividing with. You are dividing by with what? With 4 in this case, because we want to prove if it is divisible by what? By 4. So we are going to equate to 4, then we multiply this by a constant, that is to say 4 times any constant, it must be, that is what we are simply saying, it is divisible by 4. So you multiply that number by any constant of your choice. So in this case, I'm going to, let's say is equivalent to 4a, because it is by what? By 4. So times a constant that you're going to have. So from this statement, we are going to work out a lot of things. So I'm just going to leave it like this, but here, that is where we are going to work out the proof now from this part. Okay, so which means we are saying this is true. All right, now the last statement that you're going to show is that when n is now equivalent to k plus 1, if in place of n we are now having k plus 1, therefore you are the one now who is to prove. So you can write this as a statement: I shall prove that pk plus 1 is also true. So this is what you are going to do. All right, so now let us prove that this is what? This is true. We said when n is equal to k plus 1. So this type of a question, guys, you are the one who is to prove, you are the one who is to prove that this is true. So if you are the one who is to prove that this is true, you are going to substitute in place of n on the statement here. In place of n, we are now having k plus 1, which means k plus 1, k plus 1. All right, so that means p k plus 1 is equivalent to, I'm going to substitute here, 3 to the exponent of k plus 1 minus 2 into n, which is k plus 1. So this is k plus 1, and we have got minus 1. All right, so this is what we have. So like I said, this statement here is very, very important. Leave it like that. All right. So what you're going to do is to prove that this statement here that we have is going to be divisible by what? By 4. This is what you're going to do to prove from this statement. So how are you going to prove that? Okay, these are the stages that you're going to take. Since we have seen that this is our pk, I'm going to work with this expression now, which is representing what? The pk plus 1, and see if it is going to be divisible by what? By 4. So the first thing, you can actually separate your terms, because what you are going to do is you are going to substitute depending with those terms that you're going to have in terms of these terms. So as you can see, we've got 3 to the exponent of k minus 2k minus 1. So that means from this part, I can actually make 3 to the exponent of k to be the subject here. Okay, let me just put it here. 3 to the exponent of k is equal to what? If I transpose this to the other side, I'm going to obtain, let's just start with the positive 4a, the one which was already there, minus 2k to this side, it is going to give us positive 2k, minus 1 to this side is going to give us a positive 1. So what I've done, I've written 3 to the exponent of k to be the subject. That is, I've made this to be the subject of the formula. All right, so that means I am going to try by all means from this particular statement that I have to make or to have 3 to the exponent of k, so that in place of that 3 to the exponent of k, I can substitute with what? With this. Or it's maybe there's going to be minus 2, you can make minus 2 to be the subject. I don't know, you just choose what is best for you. Okay, so in this case, I'm going to choose 3 to the exponent of k. All right, so let us make this to be the subject. So what am I going to do? Let us start by having the statement down, like I said. So we are going to have this as 3 to the exponent of k plus 1 minus 2 into k plus 1 minus 1. Okay, so let's separate here, because we can see that the 3 to the exponent of k plus 1 is being affected here, that we are adding. There is a term that we are adding, and from your laws of exponents, you know this is same as 3 to the exponent of k by 3 to the exponent of 1, which is 3 times 3 to the exponent of what? Of k. All right, so it's just one and the same thing like that. So I'm going to rewrite this as 3 into 3 to the exponent of k minus, I can expand this statement, it's fine, that's minus 2 times k, which is minus 2k minus 2 times 1, which is minus 2. Then I've got minus 1 in this case. All right, so this is what I was saying. As you can see here, we have got 2 to the exponent of k here, you have got minus 2k, okay, of which on this statement, okay, I put it here. On this statement here, you can see that minus 2k is there, 3 to the exponent, so you can make any of these to be the subject. Whatever that you make to be the subject is the one that you're going to substitute here. So here I have made 3 to the exponent of k to be the subject, which is equal to 4a plus 2k. So I'm going to substitute it here in place of what? 3 to the exponent of k. Okay, so this is what I'm going to do. In place of 3 to the exponent of k, this one, I'm going to substitute with the equivalent, which is going to be 3 into our 3 to the exponent of k, which we said is equivalent to what? To 4a plus 2k plus 1. So that is 4a plus 2k plus 1. Okay, but already here we can simplify what is there. which is a minus 2 minus 1, that is a minus 3. So after substituting this 3 to the exponent of k from your pk here, now you can prove that this is going to be divisible by what? By 4. So let us prove, guys, and see what you're going to have at the end from the statement that we are going to have here. So 3 times 4, that is 12a. All right, 3 times 2, which is 6k, plus 3 times 1, which is plus 3. Okay, then here we're going to be left with minus k minus 2k minus 3. So this is minus 2k minus 3. All right, so this is what you're going to have from the expansion of brackets. I can collect like terms here, which is a 6k minus 2k, which is going to give us 4k. All right, 3 minus 3, that's a 0. So this is the statement that I'm going to have at the end. And is this statement divisible by 4? Let's cross check. If we factor out 4 here, we can have 3a plus what? Plus k. And if we had to cross check, if we divide by 4, it's divisible by 4. So this is actually true, which is divisible by what? By 4. So this is which is divisible by what? By 4. So exactly, because if you divide by 4 here, 4 into 3a plus k, like this, if you divide by 4, this will cancel. So it's divisible by 4, guys, as you can see. So that is what you're going to have, and you obtain an exact value. So the conclusion now you take from those conclusions that I showed you guys, that will be your conclusion. So you just take any one from those. So I'm going to take this one, the first one, which is for Pn, all values for Pn, all values are true. All values are true for what? We proved for P1, we proved for Pk, and we also proved for Pk plus 1, and we proved also for Pk plus 1. So we proved all these. So these are the parts that we are saying they are actually true. If we had to cross check, guys, it was actually true. So these are the typical questions that you have actually on induction. So let me show you something here. Or you can have actually your conclusion, guys. These conclusions, they are different. Okay, so I'm going to show you one of the question papers here that I'm going to work with, which is paper 2, prove by induction that whatever that you have there is a multiple of 8 for all the elements that you're going to have, which is positive integers. Okay, remember, that is what we're talking about, guys. That is, you're supposed to work with what? Positive integers. So definitely it's the introduction of the statement. So I'm going to introduce this to be my statement, which is equivalent to Pn. So that's what I'm gonna have here, which is a 5 to the exponent of 2n minus 3 to the exponent of 2n. So we want to prove that if this is exactly a multiple, so a multiple, what does it mean? This is a multiple, so it means it's divisible by 8. That is what it means. It's divisible by 8. If it is a multiple of 8, like 16 is a multiple of 8, so what does it mean? 16 is divisible by 8. So it's still one and the same question, guys. All right, so don't be afraid or don't freak out there. All right, so the first thing, when n is equal to 1, when n is equal to 1, that means P1 must be true. Okay, P1 must be true. Okay, so let's see if this is actually true. So P1, that means in place of n, I'm just going to substitute 1 in this case. That's 5 to the exponent of 2 times 1 minus 3 to the exponent of 2 times 1 in this case. And what do I obtain here? If I simplify properly, I'm going to obtain 16 here. All right, now let's cross check. Is this 16 divisible by what? By 8. Is it a multiple of 8? Yes, 16 is a multiple of 8. All right, so that means this is actually true. 16 is a multiple of 8. So this is true, which is what? Which is true. Okay, let's move on. When n is equivalent to k, now what are we going to have if our n is k? Then it means pk is also true for this one. This one, you just know that pk must be true. All right, but there's something that I showed you that I added on our proof. I hope we still have that one in mind. We said in place of k, we are going to substitute what is the value of what is the statement here? From our n, we substitute k here. So we are going to have 5 to the exponent of 2k minus 3 to the exponent of 2k, like this, which is equivalent to, guys, take note, you are going to take this 8, which is divisible, the one that is divisible by, you multiply by the constant, let's just say a constant a. So in this case, I'm going to use a to be my constant, so it's going to be equivalent to 8a, like this. So this is a statement that you are going to come back again and play around with. When I say play around with, I'm saying from this statement I can make 5 to the exponent of 2k to be the subject. That means I can write it as 5 to the exponent of 2k is equivalent to 8a minus 3 to the exponent of k. If I transpose to that side, it can be a positive 3 to the exponent of 2k. I can play around with this, or I can play around with this, take this to the right hand side, which means I'm going to be left with 5 to the exponent of 2k minus 8a, which is equal to 3 to the exponent of 2k. Still, I can see that 3 to the exponent of k can be the subject again. So you play around that statement. Why playing around the statement? Because it is the same statement that you are going to use now to prove for pk plus 1. It is the same statement that you are going to prove now when our n is equal to k plus 1, because here you shall prove that if n is like this one, if n is equal to k plus 1, then I shall prove that, you are writing the statement now, I shall prove that pk plus 1 is also true. So this is the part where you are to play the major role of mathematical induction, because you are the one now who is to prove all those statements. You are not proving anything, you are just substituting. Now you are the one who is proving. So let's prove. In place of k of n here, I'm going to have it as what? As k plus 1. So let's just write pk plus 1 in this case is equivalent to, that's going to be 5 to the exponent of what? Of 2 into k plus 1 in place of n, minus 3 to the exponent of 2, the same thing, into k plus 1, like this. So that's what you're going to have in this case, and we are saying that we must prove now. So since this, we know that this is a pk plus 1, so let us just take it down. 5 to the exponent of 2 times k, that is 2k, 2 times 1, that is 2. Remember, from your laws of exponents, you can expand this. Minus 3 to the exponent of 2 times k, that is 2k, 2 times 1, which is 2. And now let's refer back to our laws of exponents, that we know that if you are having exponents like this, which means which are adding the bases, you're multiplying the bases which are the same. So which means here I was actually multiplying what? 5 to the exponent of 2k. Let me just write it aside, because here we just need to write the exact thing. Okay, I was multiplying 5 to the exponent of 2k to 5 to the exponent of 2, and 5 to the exponent of 2 is what? Is 25 times 5 to the exponent of 2k, like this. So that is what I'm going to write it as, 25 here. So this working, you do it aside, and here you just write the exact thing, which is 5 to the exponent of 2k, like this, minus, you do the same here. Definitely you are going to have 3 to the exponent of 2, which is going to give you 9 times 3 to the exponent of 2k, like this. So this is where now you are going to substitute any one of those statements, because as you can see, 5 to the exponent of 2k is clearly represented, and 3 to the exponent of 2k is clearly separated also. So it means I can substitute any one of these statements that I had here, because remember, from this statement we said we can make 5 to the exponent of 2k to be the subject, or 3 to the exponent. So I'm just going to take this one, which is the first part here, 5 to the exponent of 2k. Okay, so substituting this in place of 5 to the exponent of 2k, it is going to look like this: 25 into 5 to the exponent of 2k, which is 8a. So it's 8a plus 3 to the exponent of 2k, which is 3 to the exponent of 2k, like this. So this is what I'm going to have at the end. So guys, take note at this stage. All right, minus 9 3 to the exponent of 2k. So this one you're just referring like it's your x or it's your y, so just leave it like that, don't simplify. Okay, but here we can multiply, guys. As you can see, 25 times 8, we can actually multiply. So you can actually use your calculator, which is going to be something like if you multiply properly. All right, this, okay, so you must actually use your calculator properly there. And this is 200 actually. So this thing of using calculator every day, you see what is now causing me, guys. Okay, anyways, this is going to be 200a, and here if you are to multiply, it's just a normal multiplication, just like 25 times x, you just write as 25x, like that. So it's the same thing. 25 times this, it is going to be 25 into 3 to the exponent of 2k, just like 25k. That is what you have. Okay, minus 9 into 3 to the exponent of 2k, like this. So this is what you're going to have. Now the question is, can I simplify? Yes, I can, because this is just like x. It's just like 25x minus 9x. You can't leave something like this. You subtract, because these are like terms. So I'm going to obtain 200a plus 25 minus 9, which is actually what? 16. So this is going to give us 16. All right, so this is 16 in this case, into 3 to the exponent of 2k. So if you are to cross check here, we can actually divide or factor out here 16. Is it possible to factor out 16? 200 divide by 16, it's not possible. So which means we can factor out 8. All right, so you can factor out 8 here, which is 200 divided by 8, which is 25. So you're going to have 25a plus, here we are going to be left, if you factor out 8, 16 divided by 8, which is 2 into 3 to the exponent of 2k, like that. So this will be our statement. Is this statement divisible by 8? Yes, it's actually divisible by 8. Is it? Was it divisible or it was a multiple, guys? Let's use the correct thing that was used. Now my question. All right, but it was divisible by, all right, it was a multiple. Okay, this was the statement. So this one is actually a multiple of 8. All right, so as you can see, this is actually a multiple of 8, because if you divide by 8, you obtain an exact thing. So which is a multiple, which is a multiple of what? Of 8. So this is one is actually a multiple of 8. So then you conclude. So guys, don't forget the conclusion I showed you. You can write any one of those conclusions. Okay, any one is the one that you're going to write. So in this case, let's say we worked with this part here. Let's say you worked with this part, you made k to be the subject, 3 to the exponent of k, like this one, which means your answer was going to be a little bit different, because it was going to look like this, because you're going to substitute from this statement. Remember, this is the major statement where we substituted here. So I'm going to take from this statement. Okay, we had 25 into 3 to the exponent of 2k, so that is 5, sorry, 5 to the exponent of 2k minus 9 3 to the exponent of 2k. So I'm just saying, if we could have substituted 3 to the exponent of 2k, maybe this is what you wanted to do. You wanted to avoid a negative on this one and just put it, it was fine, well, no matter the way. So it was going to be 5 to the exponent of 2k. So this was going to be 25 5 to the exponent of 2k minus 9, but you are now substituting in what? Place of 3 to the exponent of 2k, which is this value, 5 to the exponent of 2k minus 8a. So it's 5 to the exponent of 2k minus 8a, like that. So that is what you could have done if you wanted to work out this way. And if we are to simplify, this is just going to be 25 times 5 to the exponent of 2k. Sorry, this is 5 to the exponent of 2k minus 9 times 5 to the exponent of 2k. So it's minus 9 now times minus 8, which is going to be plus 9 times 8a. So you can actually multiply, you can just write it like that. And yes, you can see I've got like terms 25 minus 9, which is going to give us 16. So we're going to have 16 into 5 to the exponent of 2k like this, and plus 8 times 9a. So okay, just 9 times 8a like that. It's the one and the same thing. Then we can factor out 8 because you can see that 8 is common here. So we can factor out 8, which is 2 here. Factor out 8 is going to be 2 times 5 to the exponent of 2k. If I factor out 8 here, it's going to be a. So it's 9 times a, which is 9a. So this is what you're going to obtain, which is, as you can see from this one, it's actually another thing. So it depends with what you have used, but it must be true. So as you can see here, it was actually true, and here is also actually true. So that is true, guys. So you can actually work out with one of these and your conclusion. So guys, don't forget to put conclusion here. I'm just doing so that you see what you're supposed to actually do. So there you put your conclusion and so forth. So that's how these typical questions might be. So all I want you to do now is to work out these questions. I want you to try these questions, guys. Try to prove by mathematical induction. That is what you have got there. All right, another one. Try also to prove for Pn if it is always divisible by what? By 7. So I want you to prove this one if you are going to win. So don't forget to send your feedback, guys. Let me know. Also another one, I want you to try this one, which is also to prove by mathematical induction. So these are what I want you guys to actually try and see. So we shall meet again, guys, in another class working on mathematical induction, but now we shall be working on the concept of matrices and others. So there are so many ways that so many things that we actually have under mathematical induction, but that is for now. Till again.